Hello and welcome to video 17 in my Rigging in Maya series. We've come a long way, so thanks for sticking with me. What we're going to do in this video is finalise the rig you've built over the past 16 videos, giving the animator the ability to move it globally while also letting them scale him fully too. We will also investigate locking the rig down, making it bulletproof so the animator can't accidentally break it, which is a really important step. Now this may be the last time we look at this guy here, and I'm sure some of you are sick of seeing him. I know I am. I started this series a year ago now, so I'm looking forward to moving on to another character and sharing some more advanced techniques with you in the future. Okay, but first, let's finish this rig. Now before we dive in, I just wanted to mention that you can now download all the source files for each part of this Rigging in Maya series from my CubeBrush page. You can find a link in the description below. While you're there, why don't you grab some of the other tutorials, models or rigs I have on offer. Most are free, but if you would like to help contribute to these videos, all donations are welcome. Alternatively, if you enjoy these videos, why not simply treat me to a coffee as a way of saying thank you? Just head to coffee.com/antcgi. Supporters now get exclusive rewards and early access to videos, not to mention a private invitation to my very own Discord channel. Right, let's dive in. So here we have the rig so far. He has all the main controls needed for a rig of this level. Obviously, there are a lot more advanced systems we could add, but I want to save them for our next character. We have a few problems with this current rig. For one, we can see all the underlying systems, and they are easily selectable, which means the rig can be broken. Also, there is no way to move the character as a whole to reposition him in the scene. If we select everything in the outliner and move him, you can see that everything moves apart. We can try to group them, maybe that will fix it. But no, still the same issue. What's more, we can't scale him either. Doing that breaks him too. So there are a number of things we need to do before we can even think about passing this on to an animator. Let's ungroup those. A good way to quickly test the rig is to go to Display, Show All. This will make everything which isn't locked visible, something an animator could do while working, so this will expose areas which need to be locked away. We can see more of the base systems now, stretch joints, locators, all of this should be invisible. You will also notice that two new icons have appeared, and these are here on purpose. I added these because we are going to use them to help us clean up the rig. We have a route control and also a scene direction arrow. The arrow doesn't do anything directly, it's just a gentle reminder of which way the scene is pointing. This is good when you're moving a character around a lot. The route control is the main one we will be working with. You will also see that I have added a series of attributes onto this already. I've covered adding attributes a lot over this series, so I'm sure you can handle these yourself. These are here to help control the visibility of each area of the rig, but we will look more into those later. A lot of them are just simple enums. This will also act as a main global control for the character, used to reposition and scale him. Press Ctrl and G to create a new group. Rename this to male_rig_group. This will be the main group which holds the character and his rig. Select everything and drag it into the group. Just doing this simple step cleans up the outliner nicely. What we need to do now is make the character move with the route control. All we need to do is move everything under the base controls group so it is instead parented to the route control. So move all the main controls basically. Now if we move the route control, we can change the character's position and orientation. That was a simple step, but we still have a lot more to do. What's that? Ah, those are his eyelashes. I don't think I ever got around to skinning those. Oh well, I'll hide them for now and try not to get distracted. So we can move him and rotate him. But can you see there's an issue with his head? It's facing forwards no matter where the root rotates to. If we look at the head control, we can see that follow neck, which controls whether the head follows the neck or the world orientation, is set to 0, so the head is in world space. Let's reset the root. When adding the space swapping controls, which we did in the previous video, we used a locator, this one, world space position, as the main world space object. If I rotate this, you can see the head and some other elements moving with it. All we need to do is make sure these world space locators also lie under the root control. That's better, everything moves with the root, as it should. Move the root control so it's parented to the base controls group, and rename that so it's just called controls. Create a new group, again just press Ctrl and G. Call this Do Not Touch and put it in capitals so it's very clear that everything beneath this shouldn't be touched. Select the rig systems, base skeleton and male model groups. Drag these into the new Do Not Touch group. Rename base skeleton to just skeleton and male model to geometry. That cleans things up nicely. The scene is now organised and we can quickly tell what everything is. Although we should move visual aids out of the rig system group. If we don't, when we hide the systems later, these will hide too. Finally, move the Do Not Touch group into the male rig group. Nice. Okay, so we can move and rotate him. But we still can't scale him. If you do, he ends up looking bloated and his legs and arms bend. So we need to fix that next. The problem is that the other elements, like the rig systems and the skeleton, aren't parented to the root control, so aren't being influenced by its scale. We can't parent those to the root control, however. We need to maintain this hierarchy, so we need to get the root control to control their scale and nothing else. Let's hide rig systems for now so we can see a little clearer. Go to Windows, General Editors and open the Connection Editor. Select the root control. We want to keep these scale values here so we can watch the rig as we make connections. This way we will know if they are working or not. Click Reload Left to bring the root control into the Connection Editor. If you are seeing all these attributes, like me, just disable Show Non-Keyable. Now select Scale. It's pretty clear, looking at him, that the skeleton needs to be scaled. So select the skeleton group and click Reload Right to bring that into the Connection Editor too. One thing to point out is that each group's pivot must be the same as the root controls. So in this instance, it's the world root. This ensures everything scales in exactly the same way. If something doesn't look right, check your pivots first. Okay, let's change the display in the right column so we just see the main transforms. And select Scale. There, because we had scale values on the root control, we could see the skeleton change size. This has made him thinner and more in proportion, but the arms and legs are still wrong. Select the Rig Systems group and click Reload Right. Now select Scale. Again, we can see this has changed the rig and he looks like he's almost back to normal. Just like the skeleton, we needed the base rig systems to scale too. If we wanted, we could also try the geometry group, and sometimes it's worth experimenting with different groups depending on how your rig is constructed. As you can see, that does not work. The geometry is already being scaled by the joints, so adding this extra scale just makes him scale twice as much. So let's just disconnect that. Okay, he looks good overall, but we still have this issue with his knees and his elbows. This is being caused by the roll joints we added in the previous video, which allow his limbs to deform better. If you remember, we used utility nodes to make sure these joints stayed between the ones around it. So in this case, the hip and the knee. We needed this to make sure they worked alongside the stretchy limbs. Now the problem we have is we use the length of the thigh to determine the position of the roll joint, but when the rig is scaled, the length stays relative, so it does not change. So that is why the joint ends up in the wrong position. What we also need to do is factor in the overall scale when calculating the length. Close the connection editor and open the node editor. Bring the tibia and quadricep roll joints in, but also bring in the graph too, so we can see the connections. What we need are these two stretch length distance nodes. These give us the length of each joint. If we select them and graph those, we get a much clearer layout, so it's easier to work with. Let's open the left leg roll scale multiply divide node. So, the quadricep stretch length distance node gives us the length of the quadricep, or his thigh. This then goes into the multiply divide node, which takes the value and multiplies it by 0.5, essentially splitting it in half. This gives us the translation value for the roll joint, so it's always between the hip and the knee. What we also need to do is add in the scale from the root control. So this will correct any changes that are added so the roll joints remain in the right place. Duplicate the leg roll scale multiply divide node, open it up, and rename it to left leg scale offset. Let's also open the distance nodes. I'm also going to select all these nodes and press P to pin them. This should stop them all from jumping around. This was a tip that a subscriber gave to me, so thanks very much for that tip. Let's check the connections. So the quadricep length goes into input 1x. So reroute that into the input 1x attribute on the left leg scale offset node. Okay, so the tibia goes into input 1y. Let's reroute that into the same attribute on the left leg scale offset node. Open the outputs. Connect output x to input 1x on the left leg roll scale node, and output y to input 1y. So we essentially added a multiply divide node in between the distance and the current multiply divide nodes. You may notice now that the roll joints have changed position, but they aren't fixed just yet. We don't need these any longer, so delete them. The new ones are down here, so let's move them up. Just move these around. So the distance nodes are going into our new multiply divide node, but they're using the same values from the original, so we need to update those. Bring the root control into the node editor and remove all these shape nodes. Also open the control. We're going to use the scale Y attribute because that's the axis which is going to have more control over the distance nodes. To be fair, most of the time this rig will be scaled globally, so any attribute would work, but it just makes sense to use scale Y in this instance. Connect scale Y to input 2x and input 1x. So we are now going to be multiplying the length of the joints by the global scale. Now that's done, the legs look wrong again, and that's because we are multiplying when we should actually be dividing. Open the left leg scale offset node in the attribute editor. Change the operation from multiply to divide. The roll joint's positions are now fixed because the length of the joint is being divided by the scale. I can scale the rig now and the leg works. We can also still move the leg around and stretch it too. Okay, that's one limb done. Let's now update the right leg. Select the roll joints. Let's clear the node editor. Bring those and their network into the node editor and hunt down those stretch length distance nodes. Select them and graph those to remove the nodes we don't need. Open these. And duplicate the right leg roll scale node. Open this too. And rename it to right leg scale. Let's just check how these are connected so we get them the right way around. Okay, so this needs to move down here. That's better. Quadricep length goes into input 1x. We can actually reconnect the connections from the unit conversion node instead, so connect that to input 1x. And move the connection from the tibia unit conversion node to input 1y. Now connect output x to input 1x on the right leg roll scale node, and then output y to input 1y. Those are the main connections, so bring the root control in next. Remove the shape nodes again. And open this up. Just as we did with the left leg, connect its scale y to input 2x and input 2y. Finally, remember to change the node's operation from multiply to divide. That's the legs done. I'm going to repeat the process now, but this time work on the arms. But rather than go through them all again, I'm just going to speed up the video. It's exactly the same process, just using the arm roll joints instead. Okay, those are done. Stretchiness still works too, just like the legs. We can now reposition the character in the scene and we can scale him. These global controls just make things so much easier for the animator. Okay, I'll just reset these. That's the global controls done, so what's next? Well, if we go to Display, Show All, this makes all the rig systems visible. The issue here is that the animator could do this too, and will probably do it quite frequently as they work. This then means they are free to select the base systems and could move them or add keyframes onto them, which would break the rig. It's important that all this is hidden and everything is locked so it can't easily or accidentally be made visible. As I mentioned earlier in the video, the root control I imported already has a series of attributes added, which will help us to organise the rig and its systems. These are just basic attributes, but feel free to add more if you need them. Open the connection editor. Make sure the root control is in the left column. Also, go to left display, show non-keyable, so we can see our custom attributes. Here they are at the bottom. Select skeleton. Now select the skeleton group and load that into the right side. Select visibility. The skeleton is now hidden, and its visibility is only controlled through this attribute. Nice and easy, but it makes a huge difference. Next, select the rig systems attribute. Load the rig systems group into the right side and select visibility. That's the base systems safely hidden away. We still have some elements in the scene, like this locator. We have these world space position locators. The hand locators are controlled with space swapping attributes, but we should hide this main locator. Load that into the connection editor and select visibility. That is now controlled with the rig systems attribute too. I can see we have some clusters which we used for the control lines we added. I know there are a few of these and they are just called cluster. So in the outliner, I'm just going to use the filter up here to just find the nodes with cluster in the name. So I'm just going to type cluster star. That's better and it saves me searching for them. I'll just select the cluster handles and load them all into the right side of the connection editor. We can then just select all the visibility attributes to hide them. There's one left here. I'll just hide the joints for now. And the polygons so we can select it. Okay, it's selected the IK handle as this has priority, but this needs hiding too. Let's find it in the outliner. Here we go. We have the leg and the ball. I'll load them into the connection editor now and connect the visibility attributes to hide them. We have this locator here, so let's connect that too. We can select that cluster handle now and connect that. There's another IK handle here, so connect that to hide it. Let's do the same with the right leg. Connect these IK handles. And this one. Up to the arms next. Connect the right IK handle and the left. So we are slowly going around and making sure everything the animator shouldn't touch is connected to the rig systems attribute. Okay, what else? Okay, I'm going to hide the curves so we can see what's left. These locators are fine because they're used for space swapping. There are these though, which are used to drive the lips. These need to be hidden. I'm going to reveal them in the outliner first. There they are. I'm now going to press up to pick-walk up the hierarchy and select the offset groups. I will connect the rig systems attribute to the group's visibility instead. There's no particular reason for this. You could just connect directly to the locators if you wish. Okay, those are hidden now. Let's bring back the models and the joints. We have the reverse foot joints visible. Select these and find them in the outliner. We can see they are parented to the leg IK control, but we need to keep that visible. Let's use the next group down, so left bank outer. And the same on the opposite side, so right bank outer. Load those into the connection editor and select the visibility attributes. Okay, done. A good test is to just drag over the rig and see what's selectable. So we still have the ability to select the models, so let's lock those next. On the root control, I added an enum attribute called export geometry. This has three options: unlocked, wireframe and locked. These will control the geometry in the scene, so it's either unlocked and selectable, locked but you can just see the wireframe, or it's locked down completely and not selectable. So let's bring the main model into the connection editor, and on the left side select export geometry. Now we aren't going to use the visibility attribute this time because all that will do is control if we can see the model or not. Go to right display and select show non-keyable. Look for the draw override group. It will likely be greyed out. Here we go. Click the plus to open the group. All we're going to do is connect export geometry to override display type. Let's do that for the other models in the scene. Those are done. The problem is the model is still selectable. With the model selected, open the attribute editor. Open the Display tab and then Drawing Overrides. Click Enable Overrides. This makes those attributes we connected to active. If you look at the Display Type drop-down box, you will see there are three options: Normal, Reference and Template. All we did was connect our attributes to these. So Unlocked would set this to Normal, Locked sets it to Reference, and Wireframe changes it to Template. I'll just enable that for the other models. So now I can't select the model, it's locked. As you can see, the Export Geometry attribute is set to Locked. If I change it to Unlocked, it frees up the models. And Wireframe, well, switches the models so you can just see the wireframe. Okay, we are doing well. The rig systems are locked and hidden away, and the models are also locked, so can't be moved or edited. This just leaves the controls, which is all you want the animator to touch. There is still more we can do though. As we built the rig, we added lots of extra groups, like this offset group. With this one, all the main attributes have been locked and hidden away, which is great. If I check some of the other groups, yes, you see, this one is unlocked. So in theory, the animator could accidentally select this group and move it, which would break the rig. In this instance, if the animator were to animate this group instead of the knee control, there wouldn't be any keyframe on the actual control. So if the animation needs to be copied to a different rig, this animation will be lost. It sounds like it may never happen, but each animator works in their own way. So in short, it's best to also go through and lock off any groups. The good thing is, if you've kept on top of your naming conventions, you can do this really quickly with some simple mel. Open the script editor. All the way through this series, we made sure any offset groups had _offset on the end of their names. So we can use mel to search for and select all these groups for us. Type, select -r, and then specify a name of *_offset. The -r simply replaces the current selection, and the star is a wildcard, so it will select everything that has _offset at the end of the name. If I run that, all the offset groups are now selected. So all I need to do is go into the channel box, select the attributes, right click, and go to Lock and Hide Selected. We also added a series of groups when we looked at space swapping, so those need to be locked too. Again, use the same bit of mel, but change offset to space. And lock and hide those. Finally, we had some groups which we added _grp to the end. Select these and lock and hide those too, but deselect the main male rig group. We need to keep that one open. We can now go through and double check them. Yep, all locked. As a final step, go through each of the controls. You need to lock and hide any attributes which either don't affect the rig or could break the rig. So these are fine. We locked the scale attributes as we were working. The clavicle controls still have scale attributes, so I'm going to lock and hide those. It may be that in your rig you need the scale attributes, but try to only leave what's usable. So the fingers have keyframes on them, so they need removing. Because everything is locked and hidden away, I can now drag over the rig and I'm only selecting the controls. So I can now delete these keys, confident that I'm only affecting the main controls and nothing else. Again, this is something the animator may want to do if they want to key everything in at once. If you had any systems or groups selectable, they would end up with a keyframe on them, so the rig would break. That's better. So continue checking the controls. The scale attributes here could be removed, but I think we can use them to help inflate parts of the face. Okay, what's next? Okay. So we can look at wiring up some of these attributes. Open the connection editor again. The root control should automatically be in the left-hand side. Add the geometry group to the right side and connect geometry to visibility. I'll just turn off non-keyable. There we go. We can now quickly show and hide the models. Select the head control next, reveal it in the outliner, and load all the face control offset groups into the right side of the connection editor. Now connect the face controls attribute to each visibility attribute. We also added the locators too. You can see the visibility attributes are greyed out here because they are already connected, which is fine as we don't want to change them. You can now hide the face controls. This is good because usually the body is animated first and then the face later, so it makes the rig a little easier to work with. So there we go. 17 videos later, you now have a full rig which is ready to be passed on to an animator. Well done. We can double check everything by going to Display, Show, All and seeing what we can see and what we can select. You should only be able to select the controls at this stage, which is exactly where we are. Okay, well I guess we've come to the end of this part in the series. What I hope is that at this stage you know enough about rigging to be able to create your own basic biped rigs. Don't worry though, there is so much more to cover, but I wanted to say a huge thank you to you all for following along so far, subscribing and supporting me as I created this series. So what's next? Well, I want to move into more advanced areas of rigging, and to do this I need a new character, and you never know, I might actually put clothes on this one. So I hope you've enjoyed this video. If you have, please let me know in the comments below. Also let me know if you have any questions and tell me what future videos you would like to see. Remember to download the files from my QBrush page so you can follow along with these tutorials. And why not say thanks with a small donation via my Ko-fi page. As always, remember to like this tutorial and subscribe to my channel to keep up to date with future videos. This is AntCGI signing off, and I will see you on the next one.